Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Thank you very much, Master of Ceremony. We are now in the next session, the presentation of keynote speaker that will be present by 3 of keynote speaker in our event. Okay, I'd like to say thank you for all the people that attend this session. Then I'd like to have 3 of speakers today, and I'd like to briefly inform you again that first, the professor from Japan will be the presenter. There is Professor Dr. Takashi Okayasu from Kyushu University, Japan. And the second keynote speaker will be delivered by Dr. Insinyur Desria Master Engineering from IPB University, Indonesia. And the third one is by Associate Professor Dr. Muhammad Rasdi Zaini from UITM, Malaysia. And ladies and gentlemen, let's start with the first keynote speaker. And I'd like to know and asking the availability of our first keynote speaker, Professor Dr. Takashi Okayasu. Good morning, Professor Takashi Okayasu.
Good morning. My name is Takashi Okayasu. Thank you very much for inviting.
Yeah, thank you, Sensei, Professor, for your availability this morning for the presentation in our very valuable conference. And ladies and gentlemen, it's already in our screen now, the short curriculum vitae of our professor, Professor Dr. Takashi Okayasu. We can read in this screen. From Department of Agro-Environmental Science, Kyushu University, Japan. And also his major area of specialization is agricultural informatics, agricultural machinery, and computational mechanics. Membership in several academic society, Japanese Society of Agricultural Machinery, Japanese Society Agriculture Informatics, and so on. And professor have several publications that we can read also in the screen. Professor, I guess for the short introduction about you is only until this part. So I'd like to ask you to present the, I guess it's very interesting topic in this morning. So this time is for you, Professor.
It's okay?
Yes, it's clearly.
I'm sorry. So
okay,
my name is
Sensei.
Takashi Okayasu. I am in Associate Professor in Kyushu University. Thank you very much for inviting our this conference, and then I very appreciated to have opportunity to explain about my research topics. So today I want to explain about the smart agriculture based on the affordable IoT devices and verification of its validity. So as you know, the farmer is not producers. I think plants are producers. So this point is very difficult and important. So we, the farmers, have to control the environment to fit, so as to fit plant environments. So in my talk, so I mainly talk about the horticulture, using a plastic greenhouse. So by using plastic greenhouse, we can control the environment of ambient condition of a plant body. So the very important plant activity is photosynthesis. Photosynthesis is a very important activity to produce a carbohydrate from sunlight, water, and CO2. By using produced carbohydrates, the plant grow and produce the fruits and vegetables. But this combination, vegetative growth and reproductive growth, these cycle is very important. So the professional farmers can control this combination. And then they catch the big benefit. However, even if they have a good experience sense, but sometimes their management fail because the environmental condition related to so weather conditions sometimes they cannot easily predict. So to estimate or to predict such kind of environmental conditions, so we use ICT or IoT like that. So this is my research topics, but I am mainly focusing on the pre-harvest technology. But now we are conducting the post-harvesting part with collaborative researchers. This is a smart horticulture schematic diagram of smart horticulture. So we want to use IoT and ICT to optimize the cultivation management skill and method, and to reduce the production cost, total usage of resources. So today's topics or today's theme is sustainable agriculture. So this point is very important in horticulture, and to improve yield and quality. In Japan, quality of vegetable and fruits is important, but maybe in other countries also. So, do you know IOP, Internet of Plants? So, one of Japanese professor make this top name. So IOP, Internet of IoT-based agriculture production system. My study is focused on the 3 topics, so field environmental measurement and plant behavior measurement and farm work recording. Today, briefly explain about the field environmental measurement, and then I explained a little bit in detail the plant behavior management, or measurement. By using 3 data, we hope to establish and move to the sustainable agriculture. Why we can use IoT device in agriculture? So I think the price of computer is drastically cheap. So this is one of reason. We use this kind of sensors, computers with affordable sensors, temperature, humidity, CO2 gas concentration, something. This is our developed sensors, the handmade sensors. But currently, so many company, small company, a mid-scale company sell this type of the sensor. So Japanese farmers can use such kind of monitoring device. By using the measurement device, we can farmers can easily check the environmental condition, the field, and then check the plant behavior like that. Next, if now farmers can check or can obtain environmental condition, they want to control. Now they consider they want to control the environmental condition inside the greenhouse. However, the previous control system is expensive. Central control environmental control system is expensive. The Japanese farmers or horticulture grower, so their size of field is not so big, so they cannot install such kind of expensive system. So we consider affordable environmental control system using cheap computers. Maybe you know the Arduino, Raspberry Pi something. These computer can use for environmental control system as an environmental control system. This is a main controller. The controller is able to control the facilities. This is a heater in Japan. Now around 10 or 15 degrees Celsius. So after 2 weeks later, the temperature is less than 10 degrees. In that case, we cannot breed the tomato plant, so we use a heater. And then if the inside a greenhouse is become hot, so in that case, the window should be open. So this is a CO2 generator. CO2 is very important to improve the photosynthesis. And then this is a fan, and then this is a irrigation water controller. But this is the controller become cheap, and this is open software. If you want to make a heater controller, you can download the firmware from the internet and then make the device. This is my small greenhouse. This greenhouse, now we are controlling this house using affordable devices. This is this is an irrigation controller using Raspberry Pi. This is a plant, and then growing. Now this is tomato plant. Next, we are measuring the plant behavior. First, I start the plant behavior monitoring 10 years ago. I installed the camera and then capture the plant images. This is a strawberry plant. And then this part is, at that time, we took the flower, fruits, and the leaf area by using hand. But so we spend big time to get such kind of information. So this is a flower part, number of flowers. So this is time series data. And then this is unripened fruits part. This is ripened fruits part. After collecting the data, we make a graph. This is time series data, so date. And then this is number of flowers and fruits. This is a leaf area index ratio. So ratio means that this part is 1. So leaf area is go and become big and small, big and small. But this part is almost constant. Why? So this is but the number of fruits is increased, it means that the carbohydrate goes to transfer to grow the fruit part. So the carbohydrate do not transfer to the leaf growing. After reduction of the number of fruits and vegetables, so leaf area become big again. This is a combination. However, sugar content, we check the sugar content from the bricks. Bricks is not not equal to the sugar content, but this is one of index of sugar content. So the sugar content is gradually reduced because the carbohydrate transfer is not enough to the fruit part. So if farmers want to keep the sugar content inside each strawberry, in that case, they have to manage the number of flowers in this point. This is a decision making. So, but to make in this other time, we spend big time to make this graph. But now we use artificial intelligence, so deep learning, to get such kind of information. So we get this graph automatically. So this is the number of fruits. This is a white color strawberry fruits, and then this is ripened fruits. So the number of fruits is going down. It means that this part is a harvesting. So yield ratio, sorry. So you cannot see the flowers part, so you cannot see a yellow part. So no flower is coming. So this is a yellow is coming, so flower is growing again, coming again. So by using AI, we can easily check the phase transformation of cultivation state. And then this is growth curve. This is a handmade growth curve, so obtained from the data monitored by hand. So farmer's eye and researcher's eye. But this is estimated from the AI. We can get almost same growth curve. Why we need the growth curve? This part is very important for strawberry, white ripening stage. In this stage, the strawberry will improve the sugar content. So farmer should control or maintain the fertilizer amount and the content and CO2 concentration. This is a plant phenotyping system. So why we need such kind of system? To make a new variety or cultivar. So firstly, we have to check the genome. But their appearance or phenotype is closely related to environmental conditions. So many environmental factors affect the plant phenotype. So we want to correct plant phenotype under the several very various field condition and the environmental conditions. By using drone, mobile mover, and plane and some big measurement system to that these system can measure plant behavior periodically. However, one of big problem is the system is expensive. So this to reduce the cost, we use a game controller or these sensors. And so this is, as you know, this is a gaming sensor, but we use this sensor to reconstruct 2.5-dimensional images of plant. By using this sensor, RGB sensor, we can estimate the number of plant leaves and then plant height, like that. And orientation, leaf orientation. Leaf orientation is important for plant factory. By using estimated data, we can compute dry weight of plant directly. This is a phenotyping machine. So this is a testing robot in my university. So this is our plastic greenhouse. And then this is leafy vegetables. This is a strawberry plant. And then this robot move and measurement movement, and so robot can measure the plant behavior automatically. And then the control system is also provided by open source and affordable devices. So this is a short movie of plant phenotyping robot moving and take photos, and then next take photos. So by using this robot to collect this type of the data, this is the RGB plant images. This is depth images. By using depth image, we can estimate plant growth profile like that. And then plant growth profile like that also. Next, I want to introduce plant motion sensing. Camera is installed into the top of the plant and then take a photo periodically around 10 minutes and 15 minutes. But to capture the movement of the plant body, we introduce the optical flow method. So by using optical flow method, to comparing two images, we can easily estimate the movement of the, we can estimate the movement part. This part from here to there, the car is from left to right. This car is right to left, for example. We apply this method for the plant. We get the plant motion like that. The plant is always moving, and then the daytime is their movement is going down and up due to water stress. And then in the night, movement is concentrated to the growth part. Their motion is closely related to 24 hours motion interval. This is a circadian rhythm. So we plant is plant body motion can estimate from the images. So we can apply this method for catching a stress, water stress of plant like that. To measure water stress of plant, we install the low cell for upper part and the under part of plant. So we compute water balance of plant. And then to compare the water balance and the plant behavior, we estimate or capture the plant image by using RGB-D sensor. This is the result. As you can see, the temperature is going up and down, but temperature is not change. This part is a temperature is go up. So this part is a sunny day. This part is a rainy day. The water pot weight, plant weight is changed drastically in the sunny day, but rainy day does not change. This part is very interesting. So for me, the sunny day, plant motion is big. It means that, as you know, the wilting start, the plant motion become big. So rainy day does not change, but small change occur because our side window open every time. In that case, wind is coming from outside. This is a rainy day data. The weight change is small, not big. And then this part is a move. This is due to wind from the outside. But this part does not move, do not change big. So the hourly displacement of plant behavior is not so strong. Oh. Next, this is a sunny day data. As you can see, the weight change is very, very big, or comparing with the previous one. And then movement is like that. This part, though the top part is start wilting like that. So movement becomes big. By using, without water sensor, soil water content sensor, but we can estimate plant image. So we can estimate the water stress by using images like that. By using affordable sensors, we can collect many data. For example, environmental condition, environmental data, and then crop features. And now several researchers focusing on the crop flavors and farm work recordings. These images stored into the database, their data can be used for the to make make a decision and improve the farming skills, I think. Now we are using the database for improvement of the farmers' production skills. And then we want to improve the quality of fruits and vegetables, agriculture produce, And then this product has information from the production part. So the information should be transferred to the consumer part. Japanese.
Sir, excuse me, Prof.
Finish.
Are you stopping?
Okay, okay, okay.
No,
sorry. So now this is last slide.
Here.
Yeah. Okay.
So the slide is finished.
This is finished. Thank you very much. Sorry.
Oh, I see. Yeah. We are waiting whether you have something to show beside of just
sorry.
explanation.
Okay.
Okay. Thank you, Prof. Do you still need to add more information dealing with the slide share before? If not, I'd like to say it is very interesting presentation when you use computer, also software and optical flow, even a robot to to study and to have many activities dealing with production, growth, and also maybe the connection with farmer. So, ladies and gentlemen, to have the presentation from the professor. For the question and answer, let us finish all the presenter for the 3 keynote speakers finish the presentation first. So, thank you very much for the presentation for a moment. Then please wait until we will have again with question and answer.
Yep.
By the way, Prof, are you now near your robot in your greenhouse, or is it the background? Because the robot
this is background in the greenhouse. Yes.
Oh yeah. Is it working now?
Yeah, every time. Now 24 hours. Every time we
maybe
open it.
later
So each 2 hours.
in the question and answer, maybe you can show some process of the robotic activities. Okay, thank you very much for a moment, Prof. See you later at the end of the third presenter.
Okay, thank you.
Okay, thank you very much.